Okay. So our second part is verifying identities. And I think most of these we're going to be using our double angle identities. Or yeah, there's a couple. There's two that have the half angles, but I'm recording a lesson right now. Dog, go away. Go away. Look on Google Classroom and go away. So there's two that are going to be using half angle identities. Those are not the most common ones. Um, so we'll go through. I have three examples on here using mostly double angle identities, and it's still like using the ones from before as well, like our Pythagorean identities, quotient identities. Those are going to be the main ones, I think. So yeah, um, and the same rules are going to kind of apply that did before as well. That like we want to start with trying to replace everything and put it in terms of sine and cosine. On a lot of these, like both sides of the equation are going to look equally gross. So there may not be one side that's very clearly like, yes, I should start with this. But if we have stuff that's in terms of anything other than sine and cosine, that is probably the best place to start. And in problems like this one, where we have a fraction on each side, part of our goal could be to like, I want to try to get just the numerators the same and see if I can manipulate them to get just the top the same or just the bottom. So on this one, I would start with the right hand side because we have cotangents there and we don't want cotangent, we want sine and cosine. So if we just start with, where's my pen? Manipulating the right hand side and change our cotangents to sine over cosine in both cases. So we'd have sine theta over cosine theta minus 1 over sine theta cosine theta plus 1. And typically, you are correct. Okay, good job, Taylor. I was just making sure you were paying attention. So, oh my gosh, that's also not cotangent over theta, cosine over theta. I don't think that I can handle talking and writing at the same time. What was I saying? Typically, when we have fractions like this, we're not going to be able to, or we don't really want like the numerator and the denominator to interact. We're going to try to simplify them each individually. Like they're all completely different problems. And then like as a last resort, we might have to simplify stuff in that fraction together. So here, now we have our, like we just look at the top of this, cosine over sine minus 1. Then we'd want to, like if we can look at this as, we want to combine the like terms. So if we can do cosine over sine minus 1, rewrite 1 as a fraction so that we can combine it with the cosine over sine. So in this spot, I would replace that with sine over sine. And luckily the structure is the same on the denominator. We would do the same thing. I can do sine over sine. So then we're going to have like one big fraction over another big fraction. So we'd have like cosine minus sine over sine over cosine plus sine over sine. Okay, so at this point, there's two different ways to view like our next step. If we want to eliminate the fractions in the top and bottom, because we don't like having a fraction in a fraction. In order to eliminate the denominator in the top, I would multiply this by sine. That would cancel out that denominator. But I can't just multiply the top by sine without multiplying the bottom by sine, which conveniently is also the denominator in the denominator. I don't like the way that. So here, then we can cancel those out. And what we have is cosine theta minus sine theta over cosine theta plus sine theta. So we've gone through several steps and really didn't manage to make it look much nicer. So if we look at the left side, and we can look at what, I mean, we can manipulate the left side too and try to like mess this out a little bit, see if we can get it close to the right side, see what else we can do to the right side to get it close to the left side. But if we look at, for instance, the cosine of 2 theta, at our identities over here, okay, on the right-hand side I have a cosine minus sine. With my 2 theta identities, there's these three for cosine. This version has a cosine and a sine. Okay, so if I could get the left side of this to somehow equal cosine squared minus sine squared, that would be the numerator taken care of. Can I do that? Can I do something to the cosine minus sine to get cosine squared minus sine squared? If we square it, we're going to have something else in there. That's close though. No. What is cosine squared minus sine squared going to factor? Difference of squares. It's not on your sheet. No. Uh-huh. Oh, I got really excited. When we have like x squared minus y squared, how do we factor that? What do those sounds and gestures mean? Like, you know, take it, just take this and be like, over here, and then it equals. I don't know what any of those sounds really mean. And I suspect maybe you don't either. I do. What multiplies to give us x squared minus y squared? Foil. Yeah, what would you FOIL to get that? Difference of squares. I know. You do know this. Well, Liz. Why is this just me? Anyway, hold on. So, wait. X something, Y something. X and Y and X and Y. Yeah, X and
Should I write this down?
Yes, you should. Difference of squares can be factored as x plus y times x minus y. So cosine squared minus sine squared, if we factored that, would be cosine plus sine times cosine minus sine. So on the right-hand side, we have the minus.
Wait, can't we do something with the bottom? Or like multiply it, or do something to it so then we move it over here and multiply it, and then it makes the bottom of it cancel out?
We don't want to cross the equal sign. But if we need to get from a cosine minus sine to cosine squared minus sine squared, we can achieve that by multiplying this by cosine plus sine. But again, if I'm going to multiply the top of that fraction by cosine plus sine, I have to multiply
Somebody's ringing you.
the denominator by cosine plus sine. Yeah, it's my talent.
I thought it was not. Unfortunately. Was it the government calling for you?
No, it's my talent telling me I need to give blood.
You're giving blood today?
No.
Oh.
They call me and tell me to do it, though.
Mr. Brooklyn's trying to get giving blood. Are you giving blood? I don't know. I didn't talk to Darcy, so I don't think I can. I don't know.
I think they only have spots open like 5:30, something like that. Okay. So here in the numerator, I've got my cosine squared minus sine squared. So that part is done. We've shown that those are the same thing. Okay, in the denominator, the sine of 2 theta is 2 sine cosine. So over here, I'm going to have 1 plus 2 times sine cosine. Just expand that out a little bit. Okay, when we multiply the top and bottom by sine plus cosine, now in the denominator, I have cosine plus sine times cosine plus sine. We can FOIL that and multiply it out. So we'd have cosine times cosine is cosine squared plus cosine times sine plus sine times cosine plus sine squared. When we simplify that, write the top again. Cosine squared plus sine squared is 1. That's our Pythagorean identity.
That's 1. Yeah.
Cosine sine plus sine cosine. Those are the same thing.
Yeah.
They're just different order. So I have 2 sine cosine. Which conveniently is what I have over here. See? Easy peasy.
Are you lying to us? I feel like as long as you can keep all your letters straight, it won't be too bad.
And these are gonna take up more space. They're gonna be more steps than the ones that we've done previously. But as long as you just keep like moving forward, keep trying stuff, you should eventually get there in the end. And it might be a much longer route than other people would take, but that's okay. Like not everybody has to do it the same exact way.
As long as you get the right answer.
As long as you get there by legal methods. So, this one. In this case, one of these sides definitely looks grosser. Yeah.
Yeah.
Yeah, I think so. This one shouldn't take up as much room.
Okay, hold on.
Well, I at one point agreed to be on the mailing list for my talent, and they just never stopped calling me. Yeah, I'm just trying to. What?
I was reading this paper.
Oh, wait, hang on. All right. So the left side is the side we want to manipulate. What would you suggest we do first?
I think we should put overhead.
No. Good try.
I don't know. I have no idea.
What do we have an identity for?
This one? Oh, wait. Not even one.
No.
Okay, no, it's not. Don't use this at all.
We don't have a cosine of 2 theta.
What are those X's doing in there?
It's our variable instead of theta, it's x.
We should just change it to theta.
Okay. Okay, Liz's first decree is change it to 2 theta, or x to theta.
Hold on a second. What is this doing in there? Doing the last one?
It's a double angle.
A double angle. Oh. Girl, I don't know.
Okay. When we have squares in here, sine squared 2 theta.
No, just kidding.
That means that we are taking the sine of 2 theta and squaring it.
Yeah.
Okay. So it just, we put the square right next to the sine or cosine or tangent or whatever, but it really means we're doing the sine of that thing and then squaring that answer. So here we have a sine of 2 theta. We can replace that because we don't want, when we're doing our identities, we don't want to end up with like sine of 2 theta or sine of theta over 2. We want it to be just a theta or an x, whatever. So if we replace our sine of 2 theta with its identity, then what we're doing is taking this whole thing, the 2 sine theta cosine theta, and squaring that.
What's that?
So that stuff in the parentheses, if that were like instead of sine and cosine, we just had variables. So that's like 2ab squared. Means we're doing that thing times itself, and we can multiply it like the coefficients, multiply the a's, multiply the b's.
Okay.
Same thing here. So we'd have 2 times 2, sine times sine, and cosine times cosine. That that looks really dumb. 10. On the left-hand side, we have some common factors in each of those terms.
The 4 and the cosine squared theta. Yeah.
So yeah, both of these have a 4 cosine squared. If we factor that out, what we're left with is 1 minus sine squared.
Okay. Why are we like so close to something and then you're like, oh, you got it, and then they're like, no, you're stupid.
We're one step away.
1 minus, oh, that equals cosine. Oh, it does. 1 minus sine squared equals cosine squared theta.
So Pythagorean identity.
Oh, yeah.
So now we have 4 cosine squared times cosine squared, which is cosine to the 4th. And we're done. Magic. Math magic. Okay, well that's Taylor's trigger word there, I guess.
I really like math. Can you shut up? No, I'm trying to convince myself.
Do one more.
Just for shits and giggles. Kicks and giggles. Whatever you want. Shits and giggles. I don't want to have any more shit situations. Every time anybody says the word shit, I think of Mr. Coulter, and it just like makes me kind of.
Yeah.
You know how weird it was to go home and mom was like, "What happened at school today?" And there was like a lot of things that had happened that day, so I was going through, and I was like, "Oh, Mr. Coulter should have said in the hallway," and then he ran down the hallway to the bathroom, left the trail of shit, and he was like, "Oh yeah."
As happens, you know.
We're unfazed by this. How many times have we had kids on the bathroom floor in our school? Well, the kids came in, they're like, somebody shit again, and I was like, ah, darn. It was in the hallway this time, and I was like, oh, this is, oh.
See, you guys are going to be so prepared when you go out in the world.
That's what my mom says. She's like,
because you're just used to dealing with literal poo.
She was like, you guys are gonna be so great because you're gonna go to college and everybody's gonna want to be like so nice and normal, and you're gonna be like, wow, normal.
All right, which side sucks the most?
The left one.
Definitely the left. What would you like to do first?
Can't we like rearrange something there on like that second one down so that it's like because cosine squared minus sine squared equals cosine 2 theta.
Okay.
We like move something around so that it's like
So yeah, start out, replace the 2 theta. Whenever there's a double angle in there, try replacing that. Let's see what happens. What's going to happen in the inside parentheses?
I feel like somehow we can cancel those two out and then multiply the sine theta by the 2 sine theta to get sine whatever that. How do you say sine 3?
Cubed.
Sine cubed theta. I feel like I just can't prove it yet.
Because we're subtracting this. It's going to distribute the minus through there. So we would have cosine squared minus cosine squared minus a negative sign would be a positive sine squared. And then, yeah, cosine squared minus cosine squared is going to cancel out.
And then we multiply those together.
So we just have sine times sine squared, which gives us sine cubed equals sine cubed.
I can't wait to cry about this one.
Why wait?
They're cute. I'm starting.
You can cry about it here if you want to.
Yesterday,
Nobody will judge you that much.
Michaela, we were going through her like graded papers, and on the days when Stranger isn't there, me and Mary help her. And so I was like, all right, Michaela, let's look at your graded papers and see what you did. And she was getting hundreds, and she was like, oh my gosh, this is so exciting. And then out of like, I don't know if it was like pure excitement or like what it was, but she like grabbed my hand, and she like, instead of her like tickling me, I give her my hand, and then she tickles the inside of it. And she got so excited, she like licked it, and then I was like, let's not lick it. That's the germy part. So then, like, really extravagantly, she like reaches over and grabs my hand. And she flips it over and she's like, "Mwah!" And then she runs up to Mr. Buckman and is like kissing his shoulder and tickling him.
Oh, I just love her.
I do too. She's my favorite. I love when Mr. Buckman can't color. It's so funny.
He's done remarkably well.
That's what I'm saying.
Considering where he started from.
At least they acknowledge her.
Yeah. So this one we've just got 1, 2, 3, 4, 5, 6.
Okay, we can do this. This isn't bad.
And so 28 and 29 are both using half angle. And you will be able to get rid of your square roots on both of those. But still, I mean, using the same concepts, if things are in terms of something other than sine or cosine, try putting it in terms of sine and cosine first. If you have, the sine of 2 theta, replace it with your double angle. Or if you have theta over 2, replace it with your half angle. And it looks like they are all in terms of theta. There's no stupid x's in there. Liz's xist? Variablist?
I also don't like black cows.
Okay. So, work on that. Whoa.